स्वाध्याय टीवी डॉक्टर बाबा साहेब आंबेडकर ओपन यूनिवर्सिटी।
Namaste dear students, I Dr. HIMANSHU PATEL welcome you from the Chaitanya studio of Dr. Baba Saheb Ambedkar Open University. We are in lecture series on mobile application development in Android. Before we start, we must look at the previous lecture content. So, in last lecture we have learned how to create a service in Android Studio project for downloading a file. We have also learned how to implement repeated task inside service, and we learn how to use intent service and established communication between service and activity. Our today's topic is 3D graphics using OpenGL ES, that is Open Graphics Library for Embedded Devices. So, let us start. Today's agendas are: we learn about OpenGL ES introduction. There are fundamental classes available in OpenGL ES that you need to use for programming. So, we discuss those classes. Then we declare OpenGL requirement in manifest file using use feature tag, and we learn how to map coordinate specified in program onto device screen. We also learn basic shape in OpenGL ES, and finally, we create one practical example to demonstrate these capabilities. So, today we discuss very basic thing of OpenGL ES. You have to learn in depth for become expert in these OpenGL ES programming, but today we at least learn very basic things of OpenGL ES. So, let us start with what is OpenGL ES is. OpenGL ES stands for Open Graphics Library for Embedded System, and Android include support for higher performance 2D and 3D graphics with this OpenGL library, and specifically the OpenGL ES API. OpenGL is a cross-platform graphics API that specifies a standard software interface for 3D graphics processing hardware. OpenGL is a flavor of the OpenGL specification intended for embedded device. So, OpenGL ES is a not complete open graphics library, but it is a specifically designed for embedded devices. Now, we look at the different versions of OpenGL ES. You can see on the screen that the initial version OpenGL ES 1 and 1.1 is supported from the very beginning, that is Android 1 version and higher, and then from API level 8 or Android 2.2 Froyo and higher, it includes supports for OpenGL ES 2 version, and Android 4.3 with API level 18 and higher supports OpenGL ES version 3 also, and latest version of Android is Android 5.0, which is Lollipop, and its API level is 21. So, it also includes supports for OpenGL ES 3.1. Now, all versions are having backward compatibility, that means all previous versions of OpenGL ES is supported by latest version. How Android supports OpenGL ES? There are two ways. First, through its framework API, and second through native development kit, which stands for NDK. So, there are two ways you can use OpenGL ES in Android. Now, we discuss fundamental classes required to perform graphics programming using OpenGL ES. We can say there are two fundamental classes in Android framework that let you create and manipulate graphics with the OpenGL ES API. These two classes are GL Surface View, which is a place where you can draw, and how to draw is specified by these interface called GLSurfaceView.renderer. So, these are the two classes that you must use in order to draw something on your screen. So, we start one by one. First is a OpenGL surface view. So, this class is a view where you can draw and manipulate object using OpenGL API calls. So, we can say it is a main class which you need to use in your program. You can use this class by creating an instance of GL surface view and adding your renderer to it. However, if you want to capture touch screen event, you should extend the GL surface view class to implement the touch listener. So, GL surface view class use renderer which actually specifies how to draw on screen. So, first we have create instance of GL surface view and then we set its renderer for drawing something on GL surface view. Next is a GL surface view.renderer interface. This interface defines the method required for drawing graphics in GL surface view. As I mentioned earlier, you can attach these renderer to your GL surface view using set renderer method, and you need to implement three methods of these renderer. First is on surface created, second is on draw frame, and third is on surface change. So, we discuss these three methods one by one, so that you can get better idea what to write down inside these methods. So, first you have to create GL surface view, second you have to set its renderer, and inside renderer we define these three methods that we are discussed shortly. So, very first method of renderer is on surface created. The system call these method once when creating the GL surface view. Like activity life cycle, on create is created for the first time. Likewise, on surface created is called once when this GL surface view is created. You can use this method to perform actions that need to happen only once, and example is shown in red line: setting OpenGL environment parameters or initializing OpenGL graphics object. So, these method only calls once when you create your GL surface view. The second method is on draw frame. So, actually you draw and redraw inside these method, and the system calls these method on each redraw of the GL surface view. What to write down inside these method? We can use this method as a primary execution point for drawing and redrawing graphics object. The last method is on surface change. The system calls this method when GL surface view geometry changes, including changes in the size of GL surface view or orientation of the device screen. For example, if your screen change from portrait to landscape, then this method is called. We can use this method to respond to changes in the GL surface view container. Now, we learn how to declare OpenGL requirement inside your manifest file. Your application must inform that it wants to use OpenGL ES. So, if your application uses OpenGL features that are not available on all devices, you must include these requirement in your Android manifest.xml file. Suppose I want to use OpenGL ES 2.0, then I must include code shown in red line with use feature tag. So, you have to specify use feature tag, and you have to specify Android :GLES version, that is version of our OpenGL ES, and then you have to specify that it is required by specifying true inside Android : required. There are certain steps for writing OpenGL ES program. So, these steps are listed on screen. First step is to implement renderer interface, and you have to define three methods that we have discussed. Second, you have to provide the camera settings needed for your drawing in the implementation of the renderer, and you have to provide the drawing code in the on-draw method of the implementation. Then you have to construct a GL surface view. So, first step is to define renderer and its method. Broadly speaking, 1, 2, 3 creates renderer and its method. The fourth step is to construct a GL surface view, and you have to set renderer implemented in step 1 to 3 in the GL surface view, and you have to indicate you want to animation or not in the GL surface view, and finally, you have to set GL surface view and in an activity as the content view. So, once these steps are over, we set content view as our GL surface view instead of layout file in our activity file. We have to specify coordinates for drawing something on screen. So, how to specify mapping coordinates on screen? So, here you can see in first figure on left side that OpenGL considered your device screen as a perfect square and its coordinates are shown in screen. If you follow mouse pointer, the center of the screen is a origin, that is 0 0, and these top left corner point is -1, 1 and top right corner is 1 1. Similarly, bottom left corner is -1 1 and bottom right corner specifies 1.0 and -1.0. So, accordingly you have to specify coordinates for shape to be drawn. Now, suppose this is your portrait screen, first is your portrait screen and second is your landscape screen. So, when you change the orientation, it will again consider this new screen as a perfect square and your shape appearance change accordingly. So, this is how we can map coordinates onto device screen. The next is a example on real phone. Here you can see on first figure is our portrait orientation, where square looks like this, and when I change my phone orientation to landscape, my triangle is something similar to shown in figure 2. And here I use coordinates which is shown on blue color in figure. The first point is my top point, which is 0 0, 0.5 and 0 0. Now, in OpenGL we have to use 3 coordinates. First specifies x, second specifies y and third specifies z. You can see that my all z coordinates are 0 0. So, actually I am using coordinates are similar to 2D graphics, where all z's are 0. This is how mapping of coordinates done in OpenGL. How to specify these coordinates? The order in which those coordinates are drawn defines the winding direction for the shape. Suppose I am defining my coordinates as a x1 y1 z1, then x2 y2 z2 and then x3 y3 z3, which is shown on screen from first to second, second to third and third to 1. So, this is called my winding direction, and by default in OpenGL the face which is drawn counterclockwise is the front face and the back face is specified in clockwise direction. There are various methods that we have discussed which takes these GL10 public interface object as an argument. So, we discuss these interface methods. The first method is GL clear color, which specifies clear value for the color buffer. The second method is GL clear, which clear buffers to preset values, and we have GL color 4F method available, which sets the current color. For example, we can set red, green, blue or any color using this method for drawing. Then we have functions named GL draw arrays, which render primitive from array data. Now, all these functions we are going to use in our program. Then where there is a function called GL disable client state, which disable client side capability, and we have GL enable client state, which enable client side capability. Other methods are GL first UMF, which multiply the current matrix by a prospective matrix. Then we have function method named GL load identity, which replace the current matrix with the identity matrix. OpenGL use matrix for performing various tasks like rotation, resize or zooming or scaling. So, for these it stores all transformation data inside matrix. So, these functions are used for performing these kind of tasks like translation, rotation, zooming, etc. Then we have method called GL matrix mode, which specifies which matrix is the current matrix, and we have GL vertex pointer, which define an array of vertex coordinates for drawing shape, and finally we have viewport, which sets the viewports. So, these are the methods that we are going to use in our program. There are so many other methods available. For that you have to refer to OpenGLES documentation available on internet, and today we are going to write these program. We want to write an application to draw triangle in center of screen as shown in figure, and when you change orientation of your device, it should display triangle accordingly. So, let us start writing this program in Android Studio, and I have created one project already for you for demonstration. So, let us have look at this program. So, here on screen you can see I have created one project called graphics 3D demo, and we have 3 files defined inside this package with name drawing activity, which represent our main activity. We have MyGL renderer class, which is a class for specifying renderer, and we have my triangle class, which specifies triangle, and we have specified that we want to use OpenGLES in Android manifest file using use feature tag. So, first we look at this manifest file. So, here is our manifest file, and here on screen you can see we write down these line highlighted on a screen, which is use features. These tag we have already discussed. So, you must include these line in your manifest file. Next we discuss how to draw triangle. So, here is a file name mytriangle.java. How to add this file? You have to right click on this package, and then you have to select new, and then you have to define Java class. So, this is how this mytriangle file is added. So, it defines one file with name mytriangle, and here we write down various code for drawing triangle. So, first line declares one float buffer, which specifies these coordinates in memory, and here we specify coordinates for our triangle that we have also discussed in theory. First specifies top, second specifies bottom left, and last coordinates, which is a XYZ triplet, specifies bottom right. Here we have specify color. So, there are 4 arguments. First represent red portion, second green, third blue, and fourth is alpha, which is used to show transparency. So, these 4 parameter is declared for specifying our color. Now, this is our constructor, this is a constructor, and inside constructor first we have to create one memory area, which is called byte buffer. So, we have to initialize vertex byte buffer for shape coordinates. So, this is a byte buffer and here we create instance of byte buffer and these specifies that 9 coordinates memory space is to be allocated and each occupies float, that is 4 bytes. So, here first we create byte buffer, then we specify byte order for our buffer by using order method. So, here I write down byte buffer dot order and inside this I write down byte order dot native order. If you know, there are two methods for writing data into memory. First is called little endian and second is big endian. So, whatever hardware you are using, automatically it takes those order. So, first I create byte buffer, then I specify its byte order and finally we create float buffer by write down byte buffer dot as a float buffer and we want to add our coordinates into this float buffer. So, we call method put and inside this we write down array which is coordinates and finally we set buffer to read to the first coordinate by using method position and we specify 0. So, inside this constructor we specify that our data of coordinates are stored in float buffer and OpenGL can read which starts with position 0. Now, inside this draw method we have to actually specify how to draw this primitive. In constructor we just load our coordinates data into float buffer, but inside draw we actually draw these shape by reading from this float buffer. So, first you have to call this method so that OpenGL can use vertex array. So, we write down enable client state and inside this we specify that we want to read from vertex array. Then we have to specify drawing color using GL color 4F method and first 3 specifies red, green and blue part and last specifies transparency and that is a 1. Next we specify that we want to draw in green color and we specify from where our coordinates are stored using GL vertex pointer method. The first argument specifies how many points are there, second type of our data, third specifies 0 and last specifies where to read. So, if you remember, this is our memory area where our vertex are stored and finally we draw triangle using draw array method of GL10 class and here we specify that we want to draw triangle starts from 0 and number of points are 3 and once our drawing is finished we have to disable client side capability using GL disable client state method so that avoid conflict with shape that do not use it. So, this is our triangle class which specifies coordinates and how to draw these coordinates. Next we discuss renderer class. So, here is our renderer class which implements GL surface view dot renderer interface and here we declare one object of type my triangle which specifies triangle to be drawn and we discuss these 3 methods on surface created, on draw frame and on surface change in theory. So, inside on surface created we set the background color of our frame using GL clear color method. Again it takes 4 argument red, green and blue. So, here red, green and blue part are 1 and alpha is also 1. So, it displays perfect white background and finally, we create instance of our my triangle object which specifies triangle. So, these code only calls one which specifies background color and create instance of our triangle. Then this method is called to draw on GL surface view. So, first we draw background using this GL clear method, then we set matrix using GL matrix mode and we specify GL model view, then we reset matrix to its default state using GL load identity, and then we set a camera angle using this GLU locate at method of GLU class, and finally we call draw method for our triangle which actually draws on screen, and last method is on surface change, like when this method calls. So, when I change my orientation from portrait to landscape, this method is called. So, first we adjust the viewport based on geometry changes by using GL viewport method and specifies left top and height width inside this method, and we calculate new screen ratio using width and height which is a argument for this method, and then we set matrix to projection mode, reset the matrix to its default state by using GL load identity method, and finally we apply the projection matrix using GL first UMF method, and inside this we take 6 argument which is left, right, bottom, top and Z near and Z far. You can more understand all these methods by looking at its documentation, but right now this method changes our projection from portrait to landscape. So, this is all about renderer. Here we define 3 methods: on surface created, on draw frame and on surface change. Now, finally, we go to our activity file. Here on screen you can see it extend activity, and here I declare 2 objects. One is of type GL surface view which is GL view, and second is my GL renderer with name renderer. And inside on create, first we create instance of GL view by calling its constructor and specifying context as a these. Then we create instance of our renderer using new MyGL renderer, and finally we set our renderer in GL surface view using set renderer method, and inside argument we specify renderer. And here we specify that renderer mode is GL surface view dot renderer mode underscore when dirty. So, these will save your battery because renderer will only redraw the picture when it gets changed or when explicitly called. And finally, we set content view to our GL view surface. So, it will display triangle using renderer, and inside on pose we have to call pose method of GL view which is GL surface view, and inside on resume we have to call its on resume method. So, if you look at like this, first we create surface view, then we set renderer using these 2 methods, and finally we set contents view to GL surface view, and these 2 classes are defined separately for better understanding. Now, we want to run this program inside our phone. So, we click this run main activity button. So, here I am pressing this run button for running my application in real phone. Here on screen you can see my graphics 3D demo application is installed, and when I click on this icon it displays triangle in center of screen, and when I change my orientation to landscape, it will automatically change my triangle to fit in landscape mode using on surface change method. So, this is how we can draw shapes in OpenGL ES. So, friends, today we have learned basic of OpenGL ES programming, and we have draw simple triangle on screen using these renderer and GL surface view class. You can add more functionality to this program, that you can move your triangle when user touches the screen and move it to place where your finger is moved. You can also rotate triangle as user touches the screen, but for that you have to study these OpenGL ES API in great detail. I hope you enjoy this session. Thank you and happy learning.
स्वाध्यायः परमं तपः।
स्वाध्याय टीवी